Solving Systems by Graphing, Part 2. Here is the two equations that we need to solve the system for. And of course, we'll continue as we have before. Let's go ahead and identify. Here's equation 1, here's equation 2. If you're going to solve a system by graphing, then you must graph them. So in doing so, we have y equals 2x minus 4. Okay, 2x minus 4. We have to identify the slope. And the slope for the first one is 2. And the y-intercept is negative 4. Okay, so we're going to start at negative 4 with a little dot. And then our slope is 2, which is really 2 over 1. Now, it's a positive slope, which means we will go up 2 and to the right 1. So up 2, so 1, 2, and to the right 1. There's another dot. Let's draw a line. In drawing the line, we have, make sure it goes off the edge of the page there. Now, let me extend this in here. There. I'll go ahead and change the color to blue. There. Put your arrows to indicate that it goes on forever. All right. The second equation is y equals 2x minus 1. Now, we have to identify the slope and the y-intercept. The slope for equation 2 is 2, and the y-intercept is negative 1. Now, what you might have picked up on by now is that the slope for the first one was 2, and the slope for the second one is 2. There's 3 types of solutions that you can encounter when solving a system of equations by graphing. One is where the lines intersect, 2 lines that intersect. That point of intersection is a solution. The second is if the lines are parallel. If they're parallel, that means they do not touch, and the answer is no solution. Now, for parallel lines, what you have to understand is this. They will have the same slope, but different y-intercepts. So if we're looking at this, line 1 has a slope of 2 over 1, and line 2 has a slope of 2 over 1. Now, let's check out the y-intercepts. This y-intercept is negative 4, and this y-intercept is negative 1. So we're going to go ahead and graph this. So I'll put a point at negative 1 on the y-axis. It's a positive slope. It goes up 2 and then over 1 to the right. So 1, 2 over 1. Let's go ahead and graph a line. And I'll extend that line. There. And what we see, let me go ahead and change the color of that line real quick. There. What we can see is that the lines are parallel and that they do not touch. Parallel lines never touch. So the answer to this is no solution. Now, once you identify that the slopes are the same, you still have to graph it. You need to practice in graphing linear equations, so you still have to graph it. Now, you already know what the answer is, but it does reinforce your skills on practicing and graphing linear equations. Let's look at the next example. Example number 4. Now, in this example, here's the first equation, and there's the second equation. So let me change colors real quick. Let me go to green. So y equals 1 is the first equation. Now, we should know that this is a special case because there's only one variable, okay, and the variable is y, which means that the y-axis will be crossed 100% of the time, and the number is 1. So it'll be crossed 100% of the time on 1 on the y-axis, which gives me a horizontal line. Okay, gives me a horizontal line. Now let me go ahead and change colors for that. There we go. Let's do this. There we go. Let's change color now. All right, so we've got the color changed. Okay, it makes a horizontal line, as we have indicated here, at 1. Now let's look at the second one, and we'll use red. Let's write the equation, 2x plus 3. Again, it's an equation in slope-intercept form, so we'll pull out the slope. The slope is 2, and then we'll pull out the y-intercept, which is positive 3. Now, the slope is 2 over 1. We must go ahead and re-put it or reinstate it as a fraction. That means it's a positive slope, so we'll go up 2 and to the right 1. But before that, we have to have a starting point. Our starting point is right here, 3 on the y-axis. So we're going to go up 2, 1, 2, and over to the right 1. Now, if we want to find another point, then we can reverse. We know the line has to go this way, so I can go down 2 and to the right 1. Okay, so we know it's going to cross right there, but let's go ahead and graph a line. It's green. I want to go ahead and change that color to red while I'm doing it. All right, we're going to extend this line right there, and we're going to move it. There we go. And we can do this there. All right, so what we see is, put my lines here, grab that. We see that they intersect at negative 1, 1. So they intersect at negative 1, 1. Negative 1, positive 1. So for a system of equations, we graph both linear equations, and where they intersected, these particular two intersected, was at negative 1, 1. That is the solution of the system of equations. This concludes solving systems by graphing, part 2.